Hello guys, welcome to another wonderful session on differential manometer. So let's consider the question on the board. The question says, the figure below shows a compound manometer. Calculate the pressure difference between point A and B. Take specific weight of water to be 10 kilonewtons per meter cube, specific weight of mercury to be 13.6 kilonewtons per meter cube, and specific weight of oil to be 8.5 kilonewtons per meter cube. All right, so we are given the diagram. This is actually a compound differential manometer. Okay, so when you have the differential manometer to be connected in more than one coils, then it is called a compound differential manometer. Now, we are given that on this side of the pipe, we have pipe A, we have water inside this pipe, and then we have a mercury, whereas we have here to be an oil of specific gravity. Of course, it's given here as 0.85. We also have this to be mercury. Okay, the shaded region indicates that what is in that shaded region is actually what mercury, unless otherwise stated. Like in this case now, I have water here. It is quite stated that it's water that is in this pipe. It is quite stated here that it is water that we have in this pipe, but whereas I have oil here, this is just to differentiate that this is water, but this is oil. But since there's nothing shown between these two, it means since there is mercury, automatically this shaded region is also a mercury. Now we have a compound differential manometer. How do we analyze this? Just like we've done in the first case, the same principle or the same method that governs differential manometer is also the same method that governs the compound differential manometer. But now we have to do this in bits for proper understanding. Okay, what you do is, you just like it has been stated here, there's a section here. You section this place into two. If you section this place into two, it means you have two different differential manometers. You have this one, a U-Tube manometer, with which end, once you section here, it means this end is now open to the atmosphere. Same thing, we also have a different U-Tube manometer, one end connected to a pipe, and this other end now free to the atmosphere. That's the first thing to do. Bisect this into two and then obtain a different or two different differential, or to obtain two different U-Tube manometers. That's the first thing to do. So if I bisect here, what will I see? I will have something like this. Let me quickly draw this here. All right, so I will have something like this if I bisect here into two for this portion. So if I section that into two, so you simply say consider section XX. That is simply what this section here, X and X. Cutting this into two, I will have this first portion of the U-Tube manometer. Remember, what is inside there is water, so you can signify that here. And then you have mercury from here. Okay, now not forgetting the height of water in the pipe was given as 1.08 meters. So you also indicate that that becomes the height of water 1.08, please. Okay, 1.08 in meters. This is now the height of water. All right, this is the datum line for this situation. Also, on this other side, we have the height of mercury. Height of mercury here was given as 0.7 meters. So you also indicate the height of mercury here is given simply as 0.7 meters. Okay, that becomes the height of mercury on this portion. But not forgetting, please, not forgetting, take note, the height, the reason why we have 0.48 here and it is oil that is in this pipe, it simply means that the height of oil is 0.48 in meters. That's what it means. And since I have oil here as well, it also means that the height of this oil in this pipe is also what? 0.48. So automatically, both on this side and on this side, the height of oil remains 0.48. Because if I take my section point here, I will have something like this. This becomes the height of oil. So far I still have oil in this pipe, it means also that the height of oil automatically in the pipe was given as 0.48. Therefore, on this side considered as well, it means that the height of this oil left here the height of this oil remains also 0.48 in meter. So please take note of that. All right, take note of that. So you have this. Okay, so this becomes the portion of the manometer when sectioned. If I section this compound manometer, then I will obtain what is called a manometer, with one end connected to a pipe and the other end free at the atmosphere, just like this. Then we'll apply the principles of what we know in differential manometers to what? Calculate this. Okay, so we solve for this first. Remember, this is pipe A, not forgetting. This is pipe A, and the pressure head in pipe A is given as, of course, we know pressure head in pipe A is always going to be HA. So pressure head in pipe A is HA. Now you do the same thing that we've been doing since. Imagine that you section this place into two, then everything here becomes the left limb, everything here becomes the right limb. So let's do that and see. If I section here into two, this is now Y and Y. Then everything on the left portion is called the left limb. So you consider the left limb. Considering the left limb, okay, considering the left limb, therefore total pressure head is equal to, remember, at the left limb now, pressure head becomes pressure head of the pipe HA. So you indicate that HA plus pressure head of the fluid, and the fluid here in this case is water. Okay, it's stated here that the fluid is water, and specific gravity of water is always constant, 1. Therefore, you multiply 1, which is specific gravity, times the height of water in the pipe, and height of water in the pipe is 1.08. So it becomes 1 times 1.08. Okay, and that becomes the total fluid on the left limb. Remember, this is the datum line, not forgetting, this is the datum line, so which means we are not considering this mercury under. Okay, so this becomes total fluid on the left limb. Now take note, in this question it has been said that you should take specific weight of water to be 10 kilonewtons per meter cube, that of mercury to be 13.6, and that of oil to be 8.5 kilonewtons per meter cube. Then they went ahead in the question and indicate that specific gravity of mercury is 13.6, is constant, so you should know. Specific gravity of the oil now is 0.85. But let's say this specific gravity was not given to you. With these parameters here, you can also find them. For instance, let's use the specific gravity or the specific weight of oil as 8.5. To find specific gravity simply means specific weight of objects. So in this case now, oil, specific weight of oil all over specific weight of pure water, specific weight of water. Okay, and specific weight of pure water is a constant value, 9, and specific weight of water is a constant value, 9810 newtons per meter cube. So this is now equal to specific weight of oil was given here as 8.5. Kilo means by 10 to the power of 3. All over specific weight of water is of pure water is a constant value, and its value is 9.81 by 10 to the power of 3, or you can simply say 9810 newtons per meter cube. And if you carry out this value divided by this value will give you the specific weight of oil to be equal to 0.85 approximately. You have this. Okay, so should in case you're not given that the specific weight of oil is 0.85, specific weight of mercury is 13.6, just go ahead and use their values I was given here. For instance, specific weight of water was given here as 10 kilonewtons, then that becomes specific weight of water all over specific weight of pure water becomes the specific gravity of water. And specific weight of water was given here as 10 by 10 to the power of 3 divided by that of pure water, which is 9.81 by 10 to the power of 3. If you do this, you're also going to obtain approximately 1 as the specific gravity of water. So keep that in mind. All right, so it means we have this. So let's fall back here now. All right, so the total pressure head is now equal to HA plus 1 times 1.08 remains 1.08. Keeping this aside, you now consider the right limb. Considering the right limb, okay, total pressure head pH is now equal to, at the right limb, the fluid we have at the right limb is the mercury and the oil, not forgetting mercury and the oil. So if you look at the original diagram I said, you have mercury here. So far there is a portion of this oil here, it means the height of the oil is still or the same height of oil measured on this other side of the U-tube manometer. Okay, so that becomes mercury. The height of mercury here is given as 0.7, and to convert this to pressure head, I said multiply the height towards its specific gravity, and the specific gravity of oil is given as 13.6. Therefore, you have the height 0.7 multiplied by specific gravity 13.6 plus, next you find the specific or the next, you find the pressure head of the oil. The height of oil is 0.48 multiplied by the specific gravity of oil. Specific gravity of oil was given here as 0.85. Therefore, you have 0.48 multiplies 0.85, and hence pressure head is equal to 0.7 times 13.6. That gives us 9.52 plus 0.48 times 0.85. That gives us 0.408. So I have this. Okay, so at equilibrium or under equilibrium condition, I said the two quantities or the two pressure heads are equal. Under equilibrium condition, the pressure head at the left limb equals pressure head at the right limb. So if you do that, you're simply going to have, this is the pressure head at the left limb given here, HA plus 1.08. So I simply have HA plus 1.08, and this is equal to total pressure head at the right limb, which is equal to this, and we have 9.52 plus 0.48. So if you have this, I can simply send everything here down to this side of the equation. Transfer everything here down to this side of the equation. And let's see what we're going to have. I will switch the camera over to the other side, please. So transferring everything here to this side, I will simply have HA plus 1.08 minus, take note, if 9.52 cross here becomes negative, minus 9.52 also minus, if plus 0.408 crosses over here, it becomes negative. So I have minus 0.408, and this is equal to 0. Since I've transferred everything there, it becomes equal to 0. Hence, I'll have here HA, okay, so 1.08 minus 9.52 minus 0.408 will give me minus 8.848, and this is equal to 0. So you simply call this equation 1. Now this becomes the total equation. Now this becomes the total pressure head on what? This particular portion of the U-tube manometer or the compound U-tube manometer. That becomes the total pressure head of this particular portion on the compound U-tube manometer. Now you do the same thing for the other remaining portion. Let me take us back to the diagram again now. Now, considering this other portion, we have solved for the total pressure head on this portion of the U-tube manometer. Next, we now consider what? The remaining portion of the U-tube manometer, which is this portion. That's the next thing to do. We consider now this portion. So, I'm going to hold that first equation there. I will wipe this out of the board and then redraw for this other portion. Then do the same thing we've done for this portion, just in the same manner for this other portion. Obtain another what? Pressure head here. Then see how it goes. Okay. So under the same section, let's now draw what we have here. On this side, we have this. Alright, so this is exactly what we have on this other portion of the section. So if we bisect here now, this is what we have remaining. The height of mercury here is 0.6. Also, the height of mercury here is 0.6. The height of the oil remains 0.48. We also have it here 0.48. But not forgetting, the height of the oil from here down to this point was given as 0.96, and the height of mercury from this point to this point is given as 0.6. So which means we need to find the height of what? This water in pipe B. The height of the water from point B down to this point is given as 0.96, and the height of mercury from here to this point is 0.6. So we need to find the height of water in pipe B, which is simply from here to this point, and that is by what? Removing 0.6 from 0.96. So 0.96 minus 0.6 will give us 0.33. 0.36 meter. That becomes the height of the water in this pipe. Hence, height of water is given as 0.36. So we simply have there to be 0.36 in meters. So this becomes the height of water. Okay, so we have the height of water, we have the height of mercury, we have the height of the oil. This is now the situation of what we have here on the other side of the U-Tube compound manometer. Now, we also apply this our section point, call this XS, employ the same principle, section here into 2. If I section here into 2, that means this becomes my left limb. So considering the left limb, considering the left limb, pressure head is equal to, remember, the total pressure head of all the water present at that particular limb. And at the left limb, the only water at the left limb is the oil. The only fluid, at the left limb is the oil. And the oil has a specific gravity of what? 0.85. So specific gravity of this oil, X equals 0.85. And the height of the oil is given as 0.48. That means total pressure head on the left limb becomes 0.85 specific gravity multiplied by the height of the oil, which is 0.48. And if you do this, you're going to obtain 0.408. So that becomes the total pressure head on the left limb. Also, considering now the right limb, considering the right limb, total pressure head at the right limb is now equal to, at the right limb we have the pressure head due to this pipe B. So we simply call that HB. So the pressure head of pipe B is called HB, which is what we have to look for. Also, we have the pressure head of what? The oil or water in the pipe, because what is in this pipe is water, indicated here. Okay, what we have in the pipe is water. All right, so the pressure head of water becomes the specific gravity of water multiplied by the height of water. And specific gravity of water is 1. So you have plus 1 times height of water in the pipe is 0.36. So 1 times 0.36 plus. Also we have mercury on this tube. So total fluid on the tube, that's what you're considering, total fluid head on the tube. So the height of mercury is 0.6 and the specific gravity of mercury was given as 13.6. Therefore, its pressure head becomes 0.6 times 13.6. So we have that the total pressure head on the right limb becomes pressure head of the pipe B, which is HB, plus 1 times 0.36 remains 0.36 plus 0.6 times 13.6. That gives us 8.16. So this becomes the total pressure head at the right limb. Now, at equilibrium, we always know that the pressure head at the left limb equals pressure head at the right limb. Under equilibrium condition, the both pressure heads are equal. So, okay, so I'm going to switch the camera to the other side and continue the solution. Okay. All right, so under equilibrium condition, the two pressure heads are the same. So I have that 0.408, I will simply have 0.408 is equal to the pressure at the right limb, and that's equal to HB. I have here HB plus 0.36 plus 8.16. 8.16. So I simply have this. Hence, I will send 0.408 over to this side of the equation. Now, take note, please. You can easily add up 0.36 and 8.16 here to just have a single value. You can easily do that. It's still the same thing, but I choose to work with it like this. Now, sending 0.408 over to this side of the equation means I will be left with 0 here. Therefore, 0 is equal to, I have here HB plus 0.36, okay, plus 8.16 minus 0.408. And if I do this, I'll have 0 is equal to, I'll have here HB plus the whole of the 0.36 plus 8.16 minus 0.408 will give me 8.112. So this is me simply saying that HB plus 8.112 is equal to 0. Call this equation 2. Now, observe that equation 1 and equation 2 are equal. Equation 1 is equal to 0. Equation 2 is also equal to 0, which means both of them are equal. Since equation 1 and 2 are equal, therefore we equate their equation. Therefore, we simply have here HA minus 8.848 is now equal to HB plus 8.112. So if I have this, I can simply send HB over to this side of the equation and send minus 8.848 over to this side. Now, if I'm sending minus 8.848 over there, it means I'm left with HA here. So I have here HA crossing HB over to this side. Positive sign cross an equal sign becomes negative. This becomes minus HB, and that's equal to that. Now I'm left with what? 8.112 at this point. Now sending minus 8.848 over here, negative sign cross equal sign becomes positive. This is now plus 8.848. So this simply implies that the pressure head difference HA minus HP is now equal to 8.112 plus 8.848. And that simply gives us 16.960 in meters. So this becomes the pressure head difference between pipe A and pipe B. And of course, if you want to convert this to in terms of gauge pressure, okay, or absolute pressure, you can simply say PA minus PB is equal to, remember, density times gravity times the height. That becomes the height difference, which is HA minus HB. Whatever you obtain here from this multiple becomes the answer. Density is 1000, gravity is 9.81. Then you put in this value 16.960, multiply them together. That gives you the absolute pressure in terms of normal pressure. So that's how to go about that analysis. So let's go back to the original diagram for another explanation. So analyzing a compound manometer is very simple. The first idea is what? You split the manometer into two, have two different differential manometers, then carry out the principle of differential manometers to solve for the both of them. At the end of the day, you have that equation we have there. Equation 1 was equal to 0, equation 2 was equal to 0, and then you put them together, you obtain your answers. I also pointed out that if you are not given specific gravities of mercury, specific gravity of water, and that of oil, but you're given this condition that was given here, specific weight of water was given here as 10 kilonewtons per meter cube. That means to obtain the specific gravity of water, remember, specific gravity has a formula. It is simply the specific weight of the object you're talking about. In this case now, specific weight of water, okay, all over specific weight of pure water. All right, and specific weight of pure water has a constant value. Now, in this question, specific weight of water was given to us as 10 kilonewtons. So this becomes 10. Kilo means by 10 to the power of 3. All over specific weight of pure water itself is 9.81 multiplied by 10 to the power of 3. So if you do this, 10 to the power of 3 cancels out. I'm left with 10 divides 9.81. If you do this, you're going to have approximately 1 to be the specific weight of what? To be the specific gravity of water. Okay, so the same thing can also happen for what? Mercury. It becomes now this value divides by 9.81. Whatever you obtain approximately 13.6 for mercury. So should in case you weren't given the values of the specific gravities and you're given this condition, all you need to do is simply employ this equation, specific weight of the given fluid all over specific weight of pure water, and then you can obtain your specific gravity. So that's it on compound manometers, and I think that is where I will wrap it up on analysis of U-Tube manometers and the rest. So I will see you in the next video on fluid mechanics. Thanks guys, and cheers.